this question, a hat company claims that claim is an important keyword here. The mean, which is the average, hat size for a male is at least 7.25. A random sample of 12 hat sizes has a mean of 7.15. At 1% level of significance, can you reject the company's claim? Assume the population is normally distributed and the population standard deviation is also given to you as 0.27 from past studies. Since you're dealing with hypothesis testing for the mean, you're going to apply the standardized test statistic. Note that standard deviation of population is given, so that's why we are using Z rather than T. These are the steps that we need to take. You need to verify that sigma is given, which is basically just right here, 0.27. Population is either normally distributed, which is basically here on this line. We need to identify null and alternative hypotheses, identify the level of significance, find the critical value, identify the rejection region. Later on, I'll show you how to use p-value, and then calculate the standardized test statistic and check to see if the standardized test statistic is inside the rejection region or not. The claim says the mean hat size for a male is at least more than or equal to 7.25. At least, more than, or equal to. So you convert that into more than or equal to. And note that your claim and null hypothesis are the same thing. Your alternative hypothesis, its complement or its opposite, which is less than 7.25. Since you have the alternative hypothesis less than 7.25, you have a left out graph. Now, to calculate your critical value, we're going to use 1% level of significance. Let us use our calculator and check to see how to calculate this critical value. Let me share the screen with you and show you how to use calculator to find the critical value. Again, remember that you have a left-tail test and alpha is 1%. So you're going to go to second vars and go to inverse norm. The area is 1%, 0.01. Mean for standardized test statistic is 0. Standard deviation is 1, and it's a left-tail test. So when you calculate, you get negative 2.33. That's how they got Z sub 0 critical value, negative 2.33. Now that you calculate your critical value, you're going to check to see if your standardized test statistic, which is x bar minus mu divided by sigma over square root of n, is inside the rejection region or not. X bar is 7.15. X bar is the sample mean. Mu is the hypothesized population mean, which is 7.25. Sigma is given to us as 2.27 and divided by square root of 12, which is basically the sample size. Approximately, you have negative 1.28. Negative 1.28 is not inside the rejection region. It is outside the rejection region. So you're saying that, hey, since this number is outside the rejection region, we fail to reject the null hypothesis or we support the null hypothesis. Since the null hypothesis and the claim are the same thing, we support the company's claim. So again, we might be interested in using p-value rather than the rejection region. To use p-value, you have a left-tail test, which is basically the first case, the first scenario. So since it's the first case, first scenario, you're going to use left-tail test and find the p-value for that. So take a look. Here you have your calculator. You're going to go to test in statistics. And since you have a z-test, it's about the average. You're going to click on z-test. You're going to enter the statistics here. the hypothesized population mean is 7.25. Sigma for population standard deviation is 0.27. The average is for sample 7.15. And then how many people were inside this survey? 12 people. And remember that it's a left tail test, so it's less than mu sub 0. Let us do the calculation, and we calculate the p-value, which is about 10%. P-value is about 10% and a little bit below 10%, but again, it's about 10%. 10% comparing to 1%, 10% is more than 1%. So you fail to reject the null hypothesis, or you support the null, or you support the claim. Again, it doesn't matter if you use p-value or rejection region, the results must be the same.